everyone. In previous lecture we have seen what is gravitational force, then what is the universal law of gravitation and the universal gravitational constant. So gravitational force is nothing but the force of attraction between any two objects, or it is nothing but the force of attraction between the object, that is called the gravitational force. And the universal law of gravitation is nothing but F is directly proportional to the product of their masses and F is inversely proportional to the square of distance between them, and therefore the gravitational force is equal to GMM upon D square. So F is nothing but the gravitational force, or we can say the force of attraction between two objects, which is found by the formula GMM upon D square, where G is the proportionality constant and that we called it as universal gravitation constant, and the value of G is constant, that is 6.673 into 10 raised to the power minus 11 Newton meter square per kg square, and this value of G remains constant all over the universe because, and therefore it is called as universal gravitational constant. Now today we will see what you mean by the free fall and acceleration due to gravity. So what is free fall? Now what is free fall? As we know that as any object throw upward, then it always move downward towards the earth. So why the object falls downward towards the earth? It is because of the gravitational force of the earth, and therefore object falls towards the earth due to its gravitational force, and this fall of object is called as free fall. So why the object falls towards the earth? The object, whenever any object throw upward, or if we draw any object from certain height, then it always drop towards the earth, or it always move towards the earth in downward direction because of the gravitational force of the earth. So the object falls towards earth due to its gravitational force, and this fall of object is called as free fall. So what is free fall? Object falls towards the earth due to its gravitational force. Then this fall of object is called as free fall. So what do you mean by free fall? That is, the object falls towards the earth due to its gravitational force, and this fall of object is called as free fall. So the object falls towards the earth because of its gravitational force. Now what do you mean by acceleration due to gravity? Acceleration or acceleration due to gravity. Now what do you mean by acceleration due to gravity? Now whenever any object falls towards the earth, then it falls in one direction. So just like if we throw this chalk upward, then it always move in downward direction, but that direction remains same. But whenever it falls in downward direction, the direction remains same, but the magnitude of the velocity gets changed. Means at every point the magnitude of the velocity get increased. So whenever any object drop from certain height, or if we throw any object in upward direction, so when it falls downward, then the direction remains same, but at every point the magnitude of the velocity gets changed, and as there is a change in velocity, then it produces acceleration. So every object possesses an acceleration. So why this object possesses an acceleration when it falls downward? It falls downward because of the gravitational force of the earth, and therefore as it falls downward because of the gravitational force of the earth, then the object possesses acceleration. So this acceleration possessed by an object because of the gravitational force of the earth, or we can say the gravity of the earth, and therefore this acceleration possessed by an object is called as acceleration due to gravity. Because any object that falls downward towards the earth, is any object that falls downward toward the earth possess an acceleration, and that acceleration possess because of the gravitational force of the earth, and therefore this acceleration is called as acceleration due to gravity. So what do you mean by acceleration due to gravity? The acceleration possess by object due to gravitational force of earth. The acceleration possessed by object due to gravitational force of earth is called as acceleration due to gravity. So, whenever any object falls downward, then the direction of the object remains same, but at every point its velocity, the magnitude of the velocity gets changed, and as there is change in velocity, then it produces acceleration, and therefore this acceleration possessed or produced by a body because of the gravitational force of the earth, and therefore this acceleration is called as acceleration due to gravity. So acceleration possessed by object due to the gravitational force of the earth, therefore it is called as acceleration due to gravity, and this acceleration due to gravity is denoted by small letter g, and its SI unit is meter per second square, because it is nothing but the acceleration. So what is the SI unit of acceleration? Meter per second square. So this is also the acceleration, but this acceleration is because of gravity, therefore its SI unit is also same, meter per second square, and this SI unit is denoted by small letter g. Now we will see the derivation for acceleration due to gravity. So derivation for g, or derivation for acceleration due to gravity. Now, as we know that F is equal to mass into acceleration, or we can say according to the Newton's second law. According to Newton's second law, F is equal to mass into acceleration. So this is equation 1. But here the acceleration possessed by object due to the gravitational force of the earth, and therefore, so where m is mass of object and a is acceleration of object. But this acceleration is due to the gravitational force, and therefore a is replaced by acceleration due to gravity g, and therefore F is equal to mg. Now this is equation 2, and as according to the universal law, so according to universal law of gravitation, F is equal to gmm upon d square. So this is equation 3. Now from equation 2 and 3, left hand side is same, therefore right hand side is also same, and therefore from 2 and 3, mg is equal to gmm upon d square. So get cancelled, and therefore g is equal to gm upon d square. So this is the formula for acceleration due to gravity. So what is the formula for acceleration due to gravity? Gm upon d square, where g is the universal gravitational constant, m is the mass of the earth, and d is the distance between object and the earth. But now whenever we talk about the distance between object and the earth, so object may be on the earth or near the earth, and that distance is very negligible, or negligible, or is very small, which is nearly equal to the radius of the earth. So why we say that it is nearly equal to the radius of the earth? Because the acceleration due to gravity, or this force, we consider from the center of the object or from the center of the earth. So whenever we say that this is an earth, an object is near the earth or on the earth, so what is the distance between it? So force exerted from the center of the earth, and the distance between earth and the object is nothing but the radius. Or if the object is away from the earth, but that distance is too much negligible, and therefore it is considered as the radius of the earth, and therefore this d is replaced by r, and therefore g is equal to gm upon r square. So the formula for acceleration due to gravity is gm upon r square, where g is the universal gravitational constant, m is the mass of the object, and r is the radius of the earth. Why radius of the earth? Because here we consider d is equal to r. D is nothing but the distance between the two objects, that is the distance between earth and the object. But in case of earth and object, so object may be on the earth or near the earth, and therefore the distance between the earth and the distance between the object and the center of the earth is considered as the radius of the earth. Why we consider the center of the earth? Because the force is always exerted from the center of the object or from the center of the earth, and therefore we consider the radius of the earth, and therefore this d is replaced by r, and therefore the value of g is gm upon r square. So this is the derivation for acceleration due to gravity. So how we derive it? First we consider the Newton's second law, that is F is equal to mass into acceleration, where m is the mass of the object and a is the acceleration of the object. But this a is replaced by g because the object possesses an acceleration due to gravitational force, and therefore F is equal to mg. And now we use the universal law of gravitation. So according to the universal law of gravitation, F is equal to gmm upon d square. So from equation 2 and 3, if left hand side is same, then right hand side is also same, and therefore mm get cancelled, that is the mass of the object get cancelled, and therefore g is equal to, that is acceleration due to gravity, is equal to gm upon d square. But this d is replaced by the radius of the earth, therefore the value of g is gm upon r square. So whenever we talk about the any object on the earth, then the any object on the earth is under the influence of acceleration due to gravity. Means any object on the earth or near the earth are under the influence of acceleration due to gravity. Means acceleration due to gravity is incident on all the object, each small and large, or any object that are on the earth. So every object are under the influence of acceleration due to gravity. So it may be chalk, it may be dust, or anything on the earth, that is the big mountains or small stone or small atom. So everything is on the earth are under the influence of acceleration due to gravity, or we can say it is the and by acceleration due to gravity, it is nothing but the gravity. It is nothing but the acceleration possessed by an object due to the gravitational force of the earth. So gravitational force of earth is exerted on each and every object on the earth, and therefore each and every object on the earth is under the influence of acceleration due to gravity. So hope you understand what do you mean by the free fall, what do you mean by the acceleration due to gravity, and how we derive the value of g. Now we will see that is this value of g. This value of g is different at different, the value of g is different at different part of the earth. Because as we have seen, this capital G, it is the universal gravitational constant, and this value remains constant all over the universe. So wherever or you consider any planet, then this universal gravitational constant remains same. but the value of G is different for Earth, value of G is different for Moon, the value of G is different for Jupiter, Mercury, Saturn. So as we change the planet, the value of G get, that is acceleration due to G, gets changed. So Moon has its own acceleration due to gravity, Earth has its own acceleration due to gravity, then Jupiter, Saturn, Mercury, each and every planet has its own acceleration due to gravity. That is, the value of G is different at different places. It does not remain same. Even on the Earth also, the value of G never be constant. So we will see the value of G. Values of G for Earth. Now as we know that Earth is not a perfect sphere. It is not a perfect sphere. It is somewhat elliptical, just like this. So the shape of the Earth is elliptical like this. So the radius of the Earth is more along equator, and the radius of the Earth is less along poles. Now from this derivation, we can say that G is inversely proportional to R square. That is, G is equal to Gm upon R square. Upon R square means the acceleration due to gravity is inversely proportional to R square. Means if the radius of the planet get increased, then acceleration due to gravity get decreased. Or if the radius of the planet get decreased, then acceleration due to gravity get increased. Okay, so according to this relation, how the shape of the Earth is elliptical, that is, the radius of the Earth is more along equator and it is less at poles, and therefore the value of G at pole is different, the value of G at equator is different, the value of G or exactly on the Earth is different, and the value of G at the center is different. So we will see what is the value of G along poles or equator or on the surface. So as the radius, or I keep it this diagram so you can easily understand it. So this is an equator and this is pole. Okay. So first, the value of G on the Earth. On the Earth means at sea level. At sea level, the value of G on the Earth, that is at sea level, it will be 9.8 meter per second square. Then second, the value of G at equator. Now what happens at the equator? At equator, the radius will be more as compared to pole, and as the radius get increased, according to this relation, G is inversely proportional to R square. So if the radius get increased, then the acceleration due to gravity get decreased, and therefore along equator the value of G or the value of G at equator is less, and it is 9.720 meter per second square, and therefore the value of G at equator is less. Now what about the value of G at poles? The value of G at poles is more, and it is 9.832 meter per second square. So the value of G at poles is more. Why? Because the radius across or the radius along pole is less, and as the radius along pole is less, therefore the acceleration due to gravity will be more, and therefore the value of G at equator is less. Why? Because along equator the radius will be more, and as the radius is more, then the value of G will be less, and it will be 9.720. So see, the value of G at on the Earth, it will be 9.8, but at equator it will be 9.720, and the value of G at poles is more. Why? Because radius along pole is less, and therefore the value of G get increased, and it will be 9.832 meter per second square. And 4, the value of G at center of the Earth. So what is the value of G at center of the earth? If we consider at the center of the earth, so at the center of the earth, if we consider this point, then at this point the radius will be 0. And as the radius is 0, then what is the value of G? The value of G will be 0. And therefore the value of G at the center of the earth is 0. It will be 0. So these are the different value of acceleration due to gravity on the earth. So exactly on the earth, that is at sea level, the value of G is 9.8. The value of G is equator is less as compared to the value of G at pole. So why the value, there may be a question asked, why the value of G at equator is less? Because the radius of the earth along equator is more as compared to pole or than the pole, and therefore the value of G at equator is less. Or vice versa, the question may be asked, why the value of G at poles is more? Because the radius of the earth along poles is less as compared to equator, and therefore the value of G at the pole is more as compared to the equator. So the value of G at equator is 9.7, that is it is less. So at equator it is less, and at pole it will be more, and at the center of the earth the value of G is 0. Okay, so these are the different values of G. So capital G, there are the two constant. One is the universal gravitational constant, which is denoted by capital G, and the value of capital G is remain constant all over the universe or for all the planets, but the value of G changes place to place. So as we change the planet, the value of G gets changed. So hope you understand what is the derivation for G and which are the values of G for Earth. Okay. Now we have seen the acceleration due to gravity and as well as the universal gravitational constant. Now we will see what is the difference between acceleration due to gravity and the universal gravitational constant. So it is also called as gravitational acceleration. So distinguish between gravitational acceleration, that is G, and universal gravitational constant, which is capital G. So what is the difference between gravitational acceleration? Now gravitational acceleration, or we call it as acceleration due to gravity. So what is the difference between acceleration due to gravity and universal gravitational constant? So first is the definition, that is acceleration due to gravity is nothing but the acceleration possessed by an object due to the gravitational force of the earth, and that acceleration is called as acceleration due to gravity, or we can say the acceleration acquired by a body because of the gravitational force of earth. So acceleration possessed by body or object due to gravitational force of earth is called as acceleration due to gravity. And what do you mean by universal gravitational constant? So it is numerically equal to, the force between two masses of 1 kg that are separated by distance 1 meter. So universal gravitational constant is nothing but it is numerically equal to the force between two masses of 1 kg that are separated by a distance of 1 meter. That is the universal gravitational constant, and that value of G is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. So that is the numerical value. Then second, this G is always act, so acceleration due to gravity always act in a downward direction. So this, as the acceleration due to gravity always act in a downward direction, means it has a direction, and as it has a direction, therefore it is a vector quantity. So it is vector quantity, and this capital G or the universal gravitational constant does not act in any particular direction, or it does not require any direction, and therefore it is a scalar quantity. So it is scalar quantity. Always keeping in mind, acceleration due to gravity act in a downward direction, always act in a downward direction, and therefore it is a vector quantity. Then third, acceleration due to gravity, or we can also use its symbol. So it is denoted by, it is always denoted by small g, and it is always denoted by capital G. It is always denoted by small g, and the universal gravitational constant is always denoted by capital G. Then fourth point, the value of G is different at different places. So as we change the planet, then the acceleration due to gravity gets changed. Or on the earth also, the acceleration due to gravity, the value of the acceleration due to gravity gets changed. So it is different at pole, it is different at equator, it is different on the earth or at the center of the earth. So on the earth, or if we change the planet, then the value of G gets changed. So the value of G is different at different places. And fourth, the value of G remains same all over the universe. Thus, it is universal constant. So, as the value of G remains same all over the universe, and therefore it is universal constant. So, value of G, that is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square, never gets changed as we change the place or as we change the planet, but the value of G gets changed, and that is the main difference between the acceleration due to gravity and the universal gravitational constant. So this is the difference between acceleration due to gravity and the universal gravitational constant. So what is acceleration due to gravity? It is nothing but the acceleration possessed by body due to the gravitational force of the earth, and universal gravitational constant means it is numerical value to the force between two masses of 1 kg that are separated by a distance of 1 meter, and that value is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. Then the acceleration due to gravity always move in a downward direction, and therefore it is a vector quantity, but the value of G is scalar quantity because it does not require any particular direction. Then acceleration due to gravity is always denoted by small g, and the universal gravitational constant is always denoted by capital G. There is no change in the notation, and the value of G is different at different places, and the value of capital G is same at all places, and therefore it is called universal constant. So hope you understand this, understand the difference between acceleration due to gravity and universal gravitational constant. Thank you.